Hello everyone, my name is Austin Rovinsky and I'm an assistant professor at New York University. This is the 9th lecture in my mini course on physical design databases, and this lecture will focus on adding a new C++ tool to the OpenRoad application. Okay, so I have my terminal pulled up and I'm going to go ahead and go into my OpenRoad flow scripts directory. You could do this inside of just the OpenRoad directory if you just installed OpenRoad, but I again usually prefer to work inside of the OpenRoad flow scripts. So when you do this, all you need to do is go to the tools directory, then you can go inside the OpenRoad directory, and then you have everything that you need right here. So in order to add a new tool, there's actually a very nice mechanism that's already included here. The only unfortunate thing is that it's not well maintained, so it does tend to break. So if we navigate inside, it's the docs folder, and then inside this misc for miscellaneous folder, you'll find that there are these add tool files. So you can see add tool.patch, add tool files.patch, and a new tool doc example.md, which is a README file. So if we actually just take a look inside here, what you'll find is if you're familiar with diff files, you'll see some differences generated. And essentially what's going on here is that it's taken an old version of the repository and then it's found the differences between adding this new tool, which in this case is just sort of a template called tool. So you'll see that it's actually adding this class tool, and it's got this command get tool and several other things in here. Unfortunately, I believe this is not up to date, but what we can do is we can at least run it and then try to fix the places where it doesn't work. So here, what we can do is we can run the patch command, which is built in. So if we run this patch -p1 and pipe it in while we're in the source folder, then we can see that the patch tool is running, and you can see that it tried to do some replacements. So some places it failed. It says 2 out of 2 hunks, which are sort of the code chunks in the file. Some of them failed, but some of them did succeed, which makes our job easier. So what we're going to do here is actually just do a little bit of exploration into how we can fix these. So helpfully it says which file here. It's saved the failed parts. So we can go ahead and look at that. And so this is, for example, source. Need to navigate to my OpenRoad folder first. Okay, so this is going to be in source slash openroad.cc.reject. Okay, and so it looks like we've only got one thing that didn't work here. So we're going to open up this source slash openroad.cc file. And it looks like what's doing here is there's a list of include files, and it's just trying to add this one line. So if we simply scroll down, and we'll see, okay, there's a long list of include files, and it was trying to add it to the end, but this part didn't look like it. It's got this extra include file, so it didn't think that it could insert it. But we actually can just include that just fine. So we're going to insert that, and then that should be all that we need for that file. So we'll save and close that file. And now we'll look at what else failed here. So we patched our OpenRoad source file, and then we've also got, actually before that we had this source/cmakelists.txt file, which did not get properly patched. So we'll go ahead and take a look at that, the reject file, the .rej. Okay, and we've got 2 spots in here that did not work, so we'll go ahead and open that up in the other window. And it looks like there's this long list of add subdirectories, and it tried to add that there, but couldn't find it. So we'll search for that. All right, yeah. So it looks like here's our list of subdirectories, and it wasn't able to add it. So it looks like the end of the list has changed a little bit. It couldn't find it, so all we need to do is just add that in there. And so that's that top part of the file, and we can see this is still the same file but a different location. And actually what we could be doing is right here, this first number is the line number that it's trying to match. It's the line and column, I believe. So we can actually look at that. We can jump to the direct line number, assuming it's close enough. So if we jump to 331, yeah, this looks pretty different. But maybe if we look in the area, yeah, we can see that it's moved down a few spots. So it looks like there's a whole bunch of tools being added to this target link libraries. And it looks like we're just inserting tool right before these other variables at the end. So we'll go ahead and add that in, and then we'll write and save this file and exit. And those were the only 2 things that we had to fix, those files. So we'll go ahead and we'll take a moment. If we can use this git diff command, which I really like in order to show the differences, basically everything that's been changed. We started with a clean repository, and now we are taking a look at what are the differences that were changed, that were added. So we can see, like, for example, in this OpenRoad header file, we created a namespace for the tool. We added some commands for getting the tool, for initializing it. We've added some stuff to the CMake file so that it can build along with the rest of the system. Making sure to initialize, deinitialize the tool. This is just some of the boilerplate that's inside of OpenRoad about how it works internally. And that's it. That's all that was added. So that's sort of the modifications that need to be made to the OpenRoad application itself. And then the rest of it is just adding the files themselves. So there was this other add tool file, which we're now going to use. So we're going to, again, do patch p1, make sure that we're in the right directory. And then from the docs, miscellaneous, add tool files.patch, and we'll run that. And this time there's no conflicts because it was creating a bunch of new files. It wasn't trying to match any differences, it just created new files. So you can see that it's created this new source/tool folder, and then it's added several things inside of it. So we'll actually take a quick look. So if we go to the source folder, there's a whole bunch of directories for all of the other OpenRoad tools, but we'll take a look in the one that we just made, which is simply called tool. And we can see all of the things that were created. So it generated a CMake file for us, and so it's setting up this build folder, this build directory. It's we're including 2 files that we just generated, maketool.cc and tool.cc. Those are going to be our C++ source files. And then, you know, just sort of included things that it needs. So that's one thing. We're not going to go through all of this, but just some examples. I definitely encourage you to explore this on your own. You can go to the source directory, and we can look at some of those files here. So there's a maketool.cc. So I believe this is something that's really important for when your tool is being initialized. This is a little bit boilerplate. There's not too much to change here, I don't believe. But then in the tool.cc file itself, this is the important part where your tool is actually going to be doing things. So here's some constructor, destructors, member functions. There's an initialization function. Here's an example function that's being created. And so it's using, well, just printf to the screen. We'll discuss a little bit later about using the logger. But here's just an example of, just a very simple test, get something working inside of OpenRoad. So you'll see that there's other files. We'll take a quick peek inside of tool.i. And so this is going to be the swig file. This is discussed more in a different lecture, but the swig file is going to be used in order to make sure that the interface between your C++ code and the application layer is connected to the scripting layer that a user will use. And then at the same note, there's going to be a tickle file, which is a script file, sort of an internal script file for OpenRoad that's also generated. And then there's some boilerplate code here as well. So basically, if you want to make a tool, this is how you start. Everything is there for you, and you can start trying to modify things just a little bit to try to get it to do what you want it to do. And we'll discuss more about how to actually use this and make it do interesting things with OpenDB and modifying that database in a different lecture. So now that we've made all these changes, let's go ahead and actually try to build this, make sure it actually still works. So here, we don't need to do anything complicated. We can just go into our build folder, and considering OpenRoad should have already been built, we can just run make, which should automatically find out what dependencies were changed and which files it needs to update. So I'll go ahead and run that with 8 separate threads here. And hopefully it shouldn't take too long. It's only detecting the new files that it needs to build. So we'll go ahead and wait for this to finish and then come back when it's done. Okay, so that finished. It does take a little bit longer the first time you add it because the big thing that changed was that OpenRoad header file and not just the tool files. So when it touches the OpenRoad files at the top, it has to build a little bit more extensively. But usually when you only modify your own tool, it can build a little bit faster. So now that we've done that, we need to make sure to make install. And this time it should default to wherever the install folder is, because this was constructed with CMake, and CMake already set where the destination folder was. So we can run make install. It will do this quick step again, and we can see that it installed correctly to the install folder that we had before. So now we can go back down. We can head to our install folder inside OpenRoad. So this is where our files just got installed to. And we will open up the OpenRoad shell. And so now, if you want to test before versus now, you'll find that there is this toolize command, which you just saw was one of the functions that was created inside our tool. And so first thing is that it's going to say that, oh, it requires a positional argument. If you looked at the code, then you'll find that that is true. It says that it needs an argument. So let's just say 1. And so now it's doing those print statements, those fprint statements that we had earlier. And we can see that it's printing out the positional argument and the other things that it can do. So there you go. You've added your first basic OpenRoad tool, and we'll work from there, starting on the next lecture. So thank you very much for taking the time to listen to this. Thank you to Nordtech, who is helping to make this series possible through their funding. And I will see you next time.